and we'll make this link across a trunk instead. So we'll make it a trunk, and it will be able to carry VLAN 1, and we can make it carry all the VLANs in between, let's say 1 and 50, right? And we also have a VLAN 99, right? So we need it to carry that, so we'll say it'll carry all VLANs from 1 to 99, right? Wouldn't that be great? All right, so that's what we're going to do. We're going to make a trunk that can carry all VLANs from 1 to 99 across here. So what we'll do is we'll go into this switch, we'll go in the command line interface, type enable, put in our password, type conf t to get to global config mode. All right, and it's port 1 that we're talking about. So we're going to say interface FA0/1, and we'll say SW tab switch port mode trunk. All right, and that's going to make it a trunk port, right? And then we'll say switch port trunk allowed VLAN 1 through 99. All right, so now we'll type end, and we'll do a show running configuration. You can see that interface fast Ethernet 01 is now switch port trunk allowed VLANs 1 through 99, switch port mode trunk, right? And to make this work, what we're going to need to do is would be best if we did it on the other switch as well. Now there is such a thing called dynamic trunking protocol, DTP, that is enabled by default on these switches, which would actually allow this switch to sense that this one is a trunk and possibly switch its mode to a trunking mode. And I'll talk about that later. It's best to actually just statically configure the mode of this switch's F01 port to be a trunk, and that's the best way to do it. So that's what we're going to do. So we'll do that the same thing over here. We'll type enable conf t FA0/1 going into port 1 and SW tab switch port mode trunk, and then SW tab switch port trunk allowed 1 through 99. All right, and I forgot something here. I need to put VLAN 1 through 99. All right, and that's good. So now we have a trunk there. Now let's do this. We'll say end. We'll do show VLAN, and you can see from the show VLAN command, just scroll up here a little bit, that port 1 is no longer listed as belonging to VLAN 1, right? And it's not showing as belonging to VLAN 50 either, right? It's just not listed here. And that's because it's a trunk. So another thing that we can do is here, we could say show interface, and then let's put a question mark, and you can see that there's an option for trunk here. So let's put that in here. So we'll say show interface trunk, right? And you can see here that it says port 01, the mode is on, so trunk mode is on, encapsulation 802.1q protocol. This is a trunking protocol which allows VLAN tagging, so special tags as the packets go across the trunk port, they get tagged with a tag that is put into the packet that has the VLAN number on it. And you can see status trunking. And here's something interesting. I said that native VLANs had everything to do with trunks, or that when we started talking about native VLANs we needed to talk about trunks, and sure enough there it is. Notice that the native VLAN, we haven't configured it yet, but if you don't configure the native VLAN, it defaults to VLAN 1. It defaults to the default VLAN. and it shows that the VLANs that are allowed on the trunk and then the VLANs that are active right now, right? So anyway, that's pretty interesting. Now the ultimate test though is to see if this PC can communicate with this PC across our trunk. So we'll do it. We'll say ping 192.168.50.101, and 101 is replying, and it is 101 over here, and we're 102. Let's just double check that. Yep, we're 102, so that works. So our trunk is working because this PC can communicate with this PC, and the PC in VLAN 1 is also able to communicate across, and so both packets are going across the trunk. Okay, let's do something interesting. We'll slide this over and we will go into simulation mode. We'll set up a filter with only, so you can set all of these on or all of these off. We'll set up just ICMP, right? And we'll say we're going to open up this one right here and get ready to do a ping. Alright, so we're in this client right here, 102, and we're going to ping 101, right? So we'll say play, and then we'll run our ping. So there goes our ping, and you'll see there goes the packet across the network, right? And there's the ping. You can see it going, and then when it gets over here, I'm going to double click on it and take a look at it and stop this capture here. Alright, we'll just stop that. So now that we have this, let's take a look at what we grabbed. Now by going into simulation mode, we can grab packets as they travel across the network, just like we could, let's say, with Wireshark using a packet sniffer, and we can get some information from it. So we've got here, notice layer 2, this packet that we picked up has an 802.1q, notice .1q, that's the trunking protocol right in layer 2 here. And then so it's inbound, so we picked up the packet as it was coming inbound on this interface, right? And then outbound, right, it's an Ethernet 2 packet, not 802.1q. So let's look at the inbound details, and we'll see the inbound details. Here's the Ethernet 802.1q that was the trunking protocol. The tag is essentially right here, trunking protocol ID. That's this field right here, and this is another trunking field that was added to the packet right here, right? And then of course here's the IP information, the packet, right? The IP addresses, source, destination IP addresses, and ICMP, here's the code for the ping, right? The ICMP protocol. But this is cool because this is the trunking protocol right here, 802.1q, and the tag as it went across the trunk. And then the outbound details, you can see that as the packet gets ready to go outbound out to the client, the 802.1q has been stripped from the packet or from the frame, and now it's just an Ethernet 2 frame, right? There's no tag on it anymore. And just the layer 2, layer 3 information and the ping information. So that's pretty interesting. And you can kind of just capture that in real time by going into simulation mode and setting up a ping.